When the team struggle to find a solution, one of the members of one of the teams has an excellent idea, and the idea is to use Docker. Now the picture on the screen is probably very familiar to you. You probably saw it in the previous lectures. As you can see, the infrastructure or the server sits on the bottom. On top of the infrastructure is installed the host operating system. Now it could be Windows, Mac OS X, Linux, etc., etc. And on top of this sits the Docker engine. And the Docker engine is responsible for spawning container 1 and container 2. As you can see, container 1 is nothing but JDK 1.7 with Tomcat 7, and container 2 runs JDK 1.8 with Tomcat 8. So all this Docker engine is doing is to spawn multiple containers. Now remember, these containers have their own processing ability, own memory, and own volumes mounted to the host operating system, and they can interact with the host operating system or with the files on the host operating system. Just to summarize, Docker engine, as you saw on the previous slide, allows you to run different containers. Now imagine containers as good as a new virtual PC with its own memory, processing ability, and volumes. Isn't that cool? Now, pretend as if you're running a PC inside another PC. Now we call the PC which is running the container as the host, and the PC which is run by the Docker engine as the container. The difference between the host and container is very important for you to understand before you get through the samples. So I highly recommend going through this slide and the one before to get an understanding of what is a container versus what is the host machine. Now let's take a look at how the problem got resolved. So as you can see in the picture, the Docker engine sits on top of the host machine, or in fact inside the host machine, and is responsible for spawning container 1 and container 2. Container 1 runs Tomcat 7 with JDK 1.7. Container 2 runs Tomcat 8 with JDK 1.8. As you can see, both of them run on port 8080. Now remember, you might be wondering how port 8080 is shared between these two containers. Remember, these two are virtual machines, which means they're as good as a PC running inside a PC, just that it's virtual. And they have their own ports, they have their own memory. They can mount their own volumes to the operating system, and they can share volumes too. So, long story short, how do requests work? As you can see on top of the arrow, the Docker engine allows you to specify port mappings. For example, requests sent to port 5555 as an example will be forwarded to container 1, and the request sent to port 6666 will be forwarded to container 2. Now what I mean by that is 5555 and 6666 are arbitrary numbers. They could just be anything. So anything coming into 5555 will go into container 1, 6666 will go into container 2. So this way we solve the problem. So let's look at how we solve the problem for each of the team members. Team A, developers who work on different apps by developing them on Mac OS X using JDK 1.7 and Tomcat 7 can be worry-free, because when they're using Docker, it's going to be consistent across all the environments. Team B gets to use JDK 1.8 and Tomcat 8 even though they share the servers with Team A. QA, on the other hand, is happy as they get to test an application developed using the same OS. So what they test is what it was developed on. DevOps, on the other hand, gets to run the apps of both the teams on the same infrastructure with different memory requirements and different JVMs. Management is happy because there is less expense, less effort, and faster deployment. Now, remember, you probably heard of Maven for Java. All Maven does is to download all the latest and greatest version of the jar files and the dependencies. So Docker for DevOps is like Maven for Java. It allows for update of packages and easy installation of softwares and all the dependencies. We will walk through it as we go on. So a quick summary, Docker is simple and easily configurable. It's easy to develop on, has faster release cycles, faster deployment times, reduced bloat as compared to other virtualization techniques, and consistent development of software across all environments. We're going to take a look at how all of this is achieved with the samples. Stay tuned.